Cloudflare auto-mitigated the world record of 3.8 terabits per second DDoS attack. This is absolutely incredible. And look at this. Not only that, but there's 6 people on this article. How great is this? This is a real one. NSA propaganda, dude. First off, this is great NSA propaganda. Second off, Cloudflare is definitely an NSA front. You actually cannot convince me that it's not. Imagine being able to own a reverse proxy to everything on the internet. You're telling me that the government doesn't own that? Please. Okay, anyways, since early September, Cloudflare's DDoS protection systems have been combating a month-long campaign of hypervolumetric L3/4 DDoS attacks. I don't even know what that means to be level 3 or 4 DDoS attacks. See, that's how little I know about DDoS. Cloudflare's defenses mitigate over 100 hypervolumetric L3/4 DDoS attacks throughout the month, with many exceeding 2 billion packets per second. And 3 terabits per second. The largest attack peaked at 3.8 terabits per second, the largest ever disclosed publicly by any organization. Detection and mitigation was fully autonomous. The graphs show below represent the 2 separate attacks events that targeted the same Cloudflare customer and were mitigated autonomously. That is so many packets. Look at that. That packet, they're hovering at no packets. And they went all the way up to 3.8 terabits per second. That is so insane. Look at that. Look at the packets. 2.14 billion packets per second. That's a lot of packets. Great job, NSA. NSA, this is incredible work that you're doing. I love this. Cloudflare customers are protected. They are. Honestly, if there's ever been a better advertisement, dude, I have no problem that this is probably going to end up being an ad. This is a great ad, okay? This is amazing. Just showing what you do and you're doing it well. Absolutely amazing. That's more packets than Amazon. I couldn't do this one, to be honest. Skill issues. Oh, yeah. I'm skill issued for sure. Absolutely. This is an amazing ad. I'm willing to read it. Cloudflare customers are protected. Cloudflare customers using Cloudflare's HTTP reverse proxy services, e.g. Cloudflare WAF and Cloudflare CDN, are automatically protected. Cloudflare customers using Spectrum and Magic Transit are also auto-magically. Should have said magically, honestly. Big miss here, Cloudflare. You had Magic Transit and you didn't say auto-magically? Damn. You already got a wet-ass firewall. You could have easily auto-magically protected it. Magic Transit customers can further optimize their protection by deploying Magic Firewall rules to enforce a strict positive and negative security model at the packet layer. Wow, I didn't realize you could do something on a packet layer. That's pretty amazing. Had it been Vercel, it would have been bankrupt. Yes, if you would have been fronted, by the way, if you would have been fronted by some other company, you would have had at least some level of that go through. Cloudflare is very impressive. No matter what you say about the NSA, you got to admit it's pretty impressive. Other internet properties may not be safe. The scale and frequency of these attacks are unprecedented. Due to the sheer size and packets per second rates, these attacks have the ability to take down unprotected internet properties, as well as the internet properties that are protected by on-premise equipment or by cloud providers that just don't have sufficient network capacity or global coverage to be able to handle these volumes alongside legitimate traffic without impacting performance. You know what the real problem here is that I think no one is talking about? Nobody is talking about the fact that we're making every last fucking item in our house, sorry for my language, a gosh darn traffic relay. I just want to give my kids a sound device. Why the hell does my sound device need to connect to the internet? Okay, it doesn't have to connect to the internet. You are creating a botnet. And every single effing time these things connect to the internet, within 1 year, you always get some sort of notice like, hey, recall, turns out it's a huge attack vector. It's like every time. How do you fall for the same thing? Stop putting Wi-Fi on a... dude, I swear within the next year, I bet you will get coffee mugs that have Wi-Fi. So it can ping your phone that you forgot your coffee mug somewhere. And guess what? It's going to be the world's... It already exists. Fuck. Dude, how much money do I have to pay just to get regular devices with tactile touch interfaces? Right? Or tactile interfaces. I want a car where I press a button Okay, I want to be able to drive and turn down my volume without looking. I want to be able to pick up and just buy an effing light/sound device for my kids without having Wi-Fi. Just give me, dude, I will pay more money and it will cost you less to make it. Just give it to me. Why do you think I drive a 2006 Chevy flatbed pickup? Because I just want buttons. That's it. New market unlocked. IoT is the worst idea ever. IoT truly is actually the worst thing. Okay, boomer. Dude, absolutely I'm a boomer. Hell yeah, brother, I'm a boomer. That's all I want is to be a boomer. Because here's the thing. IoT is literally the devil. IoT is just the most annoying part of all of our life. Dude, it is so annoying. First off, it makes everything more expensive. Your life, it's like a tax. The worst part about this IoT movement is it's actually a tax on people. One, everything has to cost more because it has a Wi-Fi chip in it. Two, it's shitty because software is a liability at small companies. These hardware companies have no desire to maintain that, okay? They want to ship you something with the least effort software ever possible. And so you get just the world's worst software on the world's just hodgepodge thrown together piece of device that just turns into a botnet that ultimately leads to 2.14 billion packets being sent. You're part of the problem because of this effing stuff. Because no one can just make you just a thing. Hey, you know what? How about you reduce manufacturing cost? Let's reduce chip pressure. Let's reduce all these rare earth minerals that we have to hack the planet for. And we could just effing have just a light bulb, okay? Just a light bulb. That's all we want. We just want a light bulb. I don't need you to Wi-Fi me when my light bulb is about to die. You know why? Because when it turns off, I will replace the light bulb. It's like I can see that it doesn't work. Like I got eyeballs. I actually have working eyeballs in my face hole that knows when things aren't on. Dude, I don't need you to tell me that the light's about to die. Prime going full Unabomber. Dude, I can't even help it, dude. IoT is the worst. Am I okay? No, I'm not. I'm not okay. Because it is the worst. It has like ruined so many good parts of our life. Because you don't need a touchscreen for everything. It's actually really annoying. It's really annoying to have a touchscreen for everything. You know what's really fun though? Programming a button. Okay, get a little Raspberry Pi out, get a little bit of hardware, throw some wires together, and bam. It's fun. I get it. I'm on your team. It's fun. Keep it as a hobby. Okay, we don't need more juiceros. Squashing fruit, not that hard. We have devices that have been working forever. Okay, the Hoist Gracies. Okay, we already have the champion. We don't need more. Okay, keep it as a hobby. Keep it as a hobby. Nah, but you don't want the AI embedded fruit juicer? I know, but then how will I know that my toast is done? I know, these are good points. I just want to play Skyrim on my fridge. I know, sorry. Anyways, let's keep on going. Cloudflare, however, does have a network capacity, global coverage, and intelligence systems needed to absorb and automatically mitigate these monstrous attacks. Dude, I'm losing my voice again. I had a voice injury a while back, and I haven't been able to recover. If you've noticed, I don't scream and go on rants anymore as much because I actually hurt my voice cord. But this one actually was worth it. Hashtag worth it. You know what I mean? Actually, hashtag worth it to ruin my voice because of IoT, because I effing hate IoT. Okay? Worth it. Rip Tokyo. That's actually why I took out Tokyo. It's because I want to scream Tokyo. Anyways, hot water and honey. I know. I got to get on it. In this blog post, we will review the attack campaign and why its attacks are so severe. We will describe the anatomy of Layer 3 for DDoS attacks, its objectives, and how attacks are generated. We will then proceed to detail how Cloudflare... How about you just do it? There's literally no need to tell me what you're about to do to this detail. You just do it instead. You know what I mean? We have observed this attack campaign targeting multiple customers in the financial services, internet, and telecommunications industries, among others. This attack campaign targets bandwidth saturation as well as resource exhaustion of inline applications and devices. By the way, this is the most like LLM written sentence of all the time, right? Like this is what LLMs do, okay? Don't be an LLM, okay? Don't be a presentation in the early 2000s. The attacks predominantly leverage UDP on a fixed port and originated from across the globe, with larger shares coming from Vietnam, Russia, Brazil, Spain, and the U.S. UDP. Let's go. Stateless is stateless connection, right? You can actually just like send UDP places. You know, that's the beautiful part about UDP is you're just like, make it happen. And it just happens. All right, hold on 1 second, people. I just came to my, it just came to me that I should go and I should say something nice to my wife. Hold on. I love my wife and I've just been wanting to, I've just been wanting to send her like little cutesy messages. When's the mullet update? I mean, the mullet update's going to be happening. My wife will probably this weekend. She'll kind of shorten it up a little bit right here, but it's not going to look like a mullet very easily, right? It's going to take some time. I sent a little bit of UDP to my wife. No, not a big deal. The high packet rates attacks appears to originate from multiple types of compromised devices, including micro-tick devices, DVRs, the fact that I got angry about the state of the world in IoT, and then IoT is the actual answer inside this article, makes me so angry. No, this is actually not pre-read. This is me being angry about the most obvious thing in the universe that has plagued mankind for the last 10 years, and then it also turns out it plagues mankind in more than one way. It's not DVRs. DVRs, dude. Why? Why DVRs? You record signals. It's literally a timer and a recorder. Why? Also, web servers, let's just be real here. Do you even know what you're installing? Like, real talk. Do you even know what you're installing in your NPM servers? How many dependencies do you think you have? Do you go through all of those dependencies? How much do you want to bet that some of y'all actually have attack vectors just sitting on your web servers? Because think about like XZ, right? The XZ, what do you call that? Malware? It's not really malware. What the hell was XE? How do you refer to it? XE was a open source community attack on a compression library in which when it was installed, it would check for the environment, and if it believed you were in a production environment in which people aren't going to look at, it would then open up a huge backdoor for you to be able to sudo in with an SSH key, right? It was an SSH vulnerability. It was a supply chain attack. Very super sophisticated. How much do you want to bet that you probably actually have one of those that does every last kind of check, right? Reads through your environment variables, tries to understand what kind of world it's in, and then decides when to turn on and turn off, right? Anyways, orchestrated to work in tandem and flood the target with exceptionally large volumes of traffic. The high bitrate attacks appear to originate from a large number of compromised ASUS home routers, likely exploited by a CVE 9.8 critical vulnerability recently discovered by Census. Damn. The anatomy of a DDoS attack. Before we discuss how Cloudflare automatically detects and mitigates the largest DDoS attacks ever seen, it's important to understand the basics of DDoS. I assume it's just a whole bunch of devices that all go to the same place, right? And they're all sending like UDP traffic to something that has it, right? Sneaky hackers seem to have a backdoor fetish. They do. The goal of a distributed denial of a service attack is to deny legitimate users access to the service. This is done usually by exhausting resources needed to provide the service. In context of these recent layer 3/4 DDoS attacks, the resource is CPU cycles and network bandwidth. True and factual. Honestly, network bandwidth is a huge one. I mean, this is why services like Cloudflare are so important, is that they have the ability to have access to that level of bandwidth. And the reality is that's also something that's kind of scary, because then you're starting to get this weird co-location of power to where you have like one provider that protects the earth, and they could really decide what gets internet and what doesn't get internet. You know what I mean? Like that, there's something kind of scary about that. There's something, I dislike that thing. Cloudflare has a monopoly on DDoS protection. That's the scary part, which is that you also need them. Like, would you want Cloudflare to stop protecting people? No, you wouldn't. Cloudflare isn't the only game in town, though. True and factual. It's not the only one, but it is like, I'm pretty sure if you asked 90% of people in this chat here, before we say anything, I can go like this. Do you know DDoS protection other than Cloudflare? I know one other. I know two plus others. I know none. I don't even know what DDoS is. So a good percentage knows of none other, right? I didn't even know that Akamai was a DDoS protector. I thought it was just a content delivery network and server hosting via Linode. I didn't realize it was also DDoS protection. See, well, I mean, it just goes to show. See, now that you see this, do you realize? Do you see how this thing works? But one search shows that it's different. Yeah, again, I get that one search shows that it's different, but that's not how these things work, right? When people only recognize one thing, it's kind of difficult. You know what I mean? Anyways, let's keep on going. Exhausting CPU cycles. Processing a packet consumes CPU cycles. In the case of regular non-attack traffic, a legitimate packet received by a service will cause that service to perform some action. Different actions require different amounts of CPU processing. For those that don't understand effectively what's being said there, you can think of it this way, that you have a network card, and then you have an operating system. You have some piece of memory in which you actually get bytes. These bytes are then transferred into your kernel space, as I hear called. This is me just drawing it loosely because I only know it at the most upper bounds of boxes and arrows. I've never programmed at this level other than on a small device for a real-time operating system, so it's much different. But this gets put into some space we call kernel space. This then notifies your application. Your application is then able to process this. Now, if it has TCP and IP, these things might have to get unraveled, right? Because for every packet that's sent, say you send a data ABC, what actually gets added to here is a TCP IP header. That's 20 bytes, if I'm not mistaken. And then there's even like a MAC header and a footer, a MAC header and footer that I believe get attached as well. So there is stuff that's put on here, and so it has to unravel these headers and everything. It has to see, am I the target of this TCP IP packet? If I am, I need to undo it, and I need to add it to the space. I need to, go through here, and so there's all sorts of processing that's required. So even if you are answering none of these, and you're like, oh, I'm going to ignore all of them, it still requires you to look at them, which actually is a lot of stuff. And there's been a whole bunch of attacks. Like there's what's it called? Sync attacks via TCP, right? There the CPU cycles go. Yeah, there's a lot of stuff that happens behind the scenes well before it ever even gets to your application. However, before the packet is even delivered to the services, there is pre-packet work that needs to be done. Layer 3 packet headers need to be parsed and processed. So layer 3 would be IP. Layer 4 is TCP, right? But I think they're all represented as a single 20-byte header, if I'm not mistaken. Layer 3 packet headers need to be parsed and processed to deliver the packet to the current machine and interface. Layer 4 packet headers need to be processed and routed to the correct socket, if any. There are multiple additional processing steps that inspect every packet. Therefore, if an attacker sends a high enough packet rate, then they can potentially saturate the available CPU resources, denying services the legitimate users. Yeah, look at this beauty. Right? To defend against high packet rate attacks, you need to be able to inspect and discard the bad packets using as few CPU cycles as possible, leaving enough CPU to process the good packets. You can additionally acquire more or faster CPUs to perform the processing. We require more minerals. That's literally what's happening here. But that can be a very lengthy process that bears a high cost. Oh, someone's actually linking this. Oh, is that a WordPress content? Oh, damn. Yeah, so this is a TCP header format. Yeah, it has source port. Okay, so it doesn't even have, so this doesn't even have, I thought TCP and IP were under the same one, so there must be an extra little piece of header for the IP part. There must be some extra additional bit, right? And doing this quickly is what router architects get paid a ton to do quickly. Yes, I would assume. That's true. Different header, yeah. Okay, so then there's also an IP header that adds on top. I couldn't remember if TCP also had the IP transit in it as well. I couldn't remember, right? Many routers make it so that the packets don't even touch CPU. Yeah. Okay. Is Prime in a sysadmin era? No, I'm not. Big box suite, and have fun zigging, by the way. I like zig. All right, exhausting. Network bandwidth is the total amount of data per time that can be delivered to a server. You can think of bandwidth like a pipe to transport water. The amount of water we can deliver through the drinking straw is less than what we could deliver through a garden hose. If the attacker is able to push more garbage data into the pipe than we can deliver, then both the bad data and the good data will be discarded upstream at the entrance to the pipe, and the DDoS is therefore successful. Yeah, that's crazy. A nice splash of cold water. I like Zig. Zig is great. Sorry, Big Box Suite just kept talking about stuff, right? Packets are like a Russian doll. They are. I drew my thing wrong. Sorry. I thought what's it called? I thought Mac. I thought Layer 2 also added a header and a footer. I may be incorrect. I guess I must be incorrect on that one. But I thought Layer 2 also added some amount of bytes to it. You are correct. Okay. I've just never really operated in that zone, right? At that low of a level that I know what I'm doing. I mean, I've generated my own stuff that is level 3, but I've never done level 2. There's Ethernet footer, yeah. Okay. Generating DDoS attacks. If we think about what this means from an attacker point of view, when you, you realize there are similar constraints. Just as it takes CPU cycles to receive a packet, it also takes CPU cycles to create a packet. If, for example, the cost to send and receive a packet were equal, then the attacker would need an equal amount of CPU power to generate the attack as we would need to defend against it. In most cases, this is not true yet. Usually in most cases, I think Thor puts this pretty well. It's like your mana bar. For the attacker to generate an attack, it requires less mana than for you to defend the attack, which requires more mana. So you have to have a lot of mana. There is a cost asymmetry, as the attacker is able to generate packets using fewer CPU cycles than it takes to receive those packets. However, it is worth noting that generating attacks is not free and can require a large amount of CPU power. Saturating the network bandwidth can be even more difficult for an attacker. Here's an attack. Here, the attacker needs to be able to output more bandwidth than the target service has allocated. They actually need to be able to exceed the capacity of the receiving service. This is so difficult that most common way to achieve this network bandwidth attack is to use a reflection/amplification attack method. For example, DNS amplification attack. These allow the attacker to send small packet to an intermediate service, and then the intermediate service will send a large packet to the victim. Oh, I never heard of this. I've never heard of a DNS amplification attack. That's cool. That'd be a cool little read for later. In both scenarios, the attacker needs to acquire or gain access to many devices to generate the attack. These devices can be acquired in a number of different ways. They may be server-class machines from the cloud providers or hosting services, or they can be compromised devices like DVRs, routers, and webcams that have been infected with the attacker's malware. These machines together form a botnet. By the way, a webcam is crazy. Again, internet on a webcam. USB. Can we just be normal, please, for once? Can we just have HDMI or USB be our transport? Do we need internet on a webcam? I know people are going to be like, well, actually, of course you need internet on a webcam. How Cloudflare defends against large attacks. And now that we understand the fundamentals of how DDoS attacks work, we can explain how Cloudflare defends against these attacks, spreading the attack surface using global Anycast. The first not-so-secret ingredient is that Cloudflare's network is built on Anycast. In brief, Anycast allows a single IP address to be advertised by multiple machines around the world. A packet sent to that IP address will be served by the closest machine. This means that an attacker uses their distributed botnet to launch an attack. The attack will be received in distributed manner across Cloudflare's network. An affected DVR in Dallas, Texas will send a packet to Cloudflare's server in Dallas. An affected webcam in London will send packets to Cloudflare's server in London. Nice. Okay, cool. This is where I'm way out of my depth, by the way. This stuff is all super cool to me. I don't know exactly how Anycast works, but that's neat. I assume it's just a bunch of reverse proxies, and the reverse proxies can be, there's some sort of stateless lookup and forwarding to the service that actually is, and they must use some sort of header, I assume. Like I know HTTP, they use headers to route, but I don't understand how it works in like TCP connections and stuff like that. Anycast network additionally allows Cloudflare to allocate compute and bandwidth resources closest to the region that needs them the most. The densely populated regions will generate larger amounts of legitimate traffic, and the data centers placed in those regions will have more bandwidth and CPU resources to meet those needs. Sparsely populated regions will naturally generate less legitimate traffic, so Cloudflare data centers in those regions can be sized appropriately. Since attack traffic is mainly coming from compromised devices, those devices will tend to be distributed in a manner that matches normal traffic flows, sending the attack traffic proportionally to data centers that can handle it. And similarly, within a data center, traffic is distributed across multiple machines. Oh, that makes sense, yeah. More people, more traffic, more people, more devices that get compromised. Additionally, for high bandwidth attack, Cloudflare network has another advantage. A large proportion of traffic on the Cloudflare network does not consume bandwidth in a symmetrical manner. For example, an HTTP request to get a web page from a site behind Cloudflare will be relatively small incoming packet, but produce a large amount of outgoing traffic back to the client. This means that Cloudflare network tends to get to egress far more legitimate traffic than we receive. However, the network links and bandwidth allocated are symmetrical, meaning there is an abundance of ingress bandwidth available to receive volumetric attack traffic. Oh, okay, that makes sense. Okay, cool. And all this should make a lot of sense because, you go to any modern JavaScript page and it downloads like 10 megabytes of JavaScript. So that seems right. You send a very small HTTP request. I need to get /. Well, okay, so what it basically means is that if assuming we're using HTTP1, HTTP has a request line, headers, and then body. Typically, for chunked encoding, it also has tails, which is kind of interesting. Tails are headers, but different. Anyways, so the idea here is a request line can be something as simple as this. When you go and get a web page, it looks something like this. It looks like it does a get. Here, I'm just going to type this out in a browser because honestly, it's just way easier. So if I were to do something in a, if this was a HTTP request, it literally could be like get slash HTTP slash 1.1, and there you go. And then you're going to, by just simply doing this, this is all you really need to make a request. You don't actually, you might have to have /r/n/r/n to say, hey, there's no headers here and there's no body. Right? Like this is effectively all you need. You can demonstrate with curl. Curl adds a whole bunch of stuff. I wanted to add with much less, right? And this can fit into a TCP packet. Typically, a packet on the internet, I think, is like, it's like 1446 or something like that. I forget the size of the packet you need, but it's extremely small amounts of data. And this is all you really need. A registered nurse, yeah, 2 registered nurses go on here. And so this theoretically could generate, if you go to, say, facebook.com and you make this request, you would possibly generate out just HTML and a very large amount of data. This thing being what? This thing being like 12 bytes. This thing being, potentially 1 meg. Right? So you can see here why it's an asymmetric attack in the sense that for you to create a lot of traffic requires actually a relatively small amount of data. 2 nurses, 1 packet. It's true. It's very true. 2 nurses are in 1 packet, data and computation, yeah. By the time you've reached an individual server inside a data center, the bandwidth of the attack has been distributed enough that none of the upstream links are saturated. That doesn't mean the attack has been fully stopped yet, since we haven't dropped the bad packets. To do that, we need to sample traffic, qualify an attack, and create rules to block bad packets. Sample traffic and dropping bad packets is the job of our L4 drop component, which uses XDP, Express Data Path, and leverages an extended version of the Berkeley packet filter known as eBPF, extended BPF. This enables us to execute custom code in kernel space and process, drop forward, or modify each packet directly at the network interface card, NIC level. That's cool. This component helps the system drop packets efficiently without consuming excessive CPU resources on the machine. That's super cool. I've never played with eBPF. All that stuff just sounds so much fun. I just would have to have like something that I actually need to do because it's hard for me to just simply do it for the sake of doing it without having like a goal. I need like a goal to actually do something with, and then I feel like I can use it to the depth where I actually understand it. Is a registered nurse just an indicator that the data ends? It goes request line, register nurse, each header, registered nurse, and then it goes a empty header, registered nurse, then your body, and then the tail. But the tail is like a special one. So build your own DDoS protection service. I'd have to do that, right? It's hard to finish a project when it's goalless, exactly. Right? So where's the mullet? It's growing. Mullets don't appear overnight, people. We use XDP to sample packets to look for suspicious attributes that indicate an attack. The samples include fields such as the source IP, source port, destination IP, destination port protocol, a TCP flag, sequence numbers, options, packets, rates, and more. This analysis is conducted by the denial of service daemon Dosti. Not a DDoS, but a Dosti. Dosti holds our secret sauce. It has many filters which instruct it based on our curated heuristics when to initiate mitigation. Just like CrowdStrike. I wonder if they also have a channel file. To our customers, these filters are logically grouped by attack vector and exposed at the DDoS management rules. Our customers can customize their behavior to some extent as needed. As it receives samples from XDP, Dosti will generate multiple permutations of fingerprints for suspicious traffic patterns. Then, using data streaming algorithm, Dosti will identify the most optimal fingerprints to mitigate the attack. Once an attack is qualified, Dosti will push a mitigation rule inline as eBPF programmed to surgically drop the attack traffic. This would actually be fun. So right now we're building a game server. It could be really fun to try to do something like this, right? Where I use eBPF to drop all packets that aren't to a specific thing, and then also potentially do some sort of like check in the path packet. Like there could be a lot of cool stuff that I could try. Not that I actually know what to do. eBPF is the JavaScript of the kernel. Oh, nice. Nice. It's interpreted. Let's go. The detection and migration of an attack by Doucette is done at the server level, at the data center level, and at the global level, and it's all software defined. This makes our network extremely resilient and leads to the almost instant mitigation. There are no out-of-path scrubbing centers or scrubbing devices. Instead, each server runs the full stack of Cloudflare product suite, including the DDoS detection and mitigation component, and it is all done autonomously. Each server has also gossips, multicast mitigation instructions within a data center between servers and globally between data centers. This ensures whether the attack is localized or globally distributed. Doucette will have already installed mitigation rules inline to ensure a robust mitigation. That's super cool. Dude, that is so super cool. I want to know more about that. I want more of this. Our software-defined autonomous DDoS detection and mitigation system run across our entire network. In this post, we focus mainly on our dynamic fingerprinting capabilities, but our arsenal of defense systems is much larger. The advanced TCP protection system, the advanced DNS protection system, alongside our dynamic fingerprinting to identify sophisticated and highly randomized TCP-based DDoS attacks, and also leverage statistical analysis to thwart complex DNS-based DDoS attacks. Our defense also incorporate real-time threat intelligence, traffic profiling, and machine learning classification as a part of our adaptive DDoS protection. That's cool. To mitigate the traffic anomalies. Together, these systems, alongside a full breadth of Cloudflare security portfolio, are built atop Cloudflare network, one of the largest networks in the world, to ensure customers are protected from the largest attacks in the world. This is super cool. You know what? People can yap all they want about all the stuff. They can yap, which they do. They just are yap machines. But when you toss in this thing right here, this is where the yapping stops. You're like, oh yeah? We also dropped 2.14 billion packets per second that were bad. And we can anycast that. And even though it's distributed across, or we can gossip it across all of our services across the entire world. So as this thing becomes a global DDoS attack, they're able to then grab it. Yeah, I know. This is a very suspicious number, by the way. This 2.14 billion packets per second is an exceptionally suspicious number. If I'm not mistaken, what is 2 to the 31 minus 1? Like, I'm just saying, that's an exceptionally suspicious number. I wonder if they actually got more packets. They just literally they did some sort of saturating ad where they actually maxed out. I think it was maxed out. I actually think they could be wrong. I think they might have did some sort of preventative rolling over saturated ad on something, and they're just landing there. Or, I mean, what are the chances that it just happens to fall within an int max? If that's the case, why are they using signed integers? You're correct. That's the only obvious hole to what I'm saying. Using a 32-bit signed integer as a counter is cringe. Yes, it is. Or the attacker used an int32 to manage the packets. That's funny. There's an int32 somewhere in there. Can we agree? Is Prime a ghost? I am. They call me Ghosty. Brother Yapsine mentioned, honestly. Yes, Brother Yapsine was somewhere in there. There's a signed integer that's 32 bits. Where is it? I don't know. But it's very funny. Coincidence? Maybe. It's pretty hard to say that that's a coincidence. I don't know. It's constantly bumping up to 2.14 billion. The idea of responding back to a request with 1 TB sized response. If DDoS protection is such a great idea. Next project idea. Yeah, I mean, there's some good stuff that I'd like to do. Obviously, there's some great stuff I'd like to do with all of this. I'd really like to it'd be fun. The thing is I wonder, I probably have to move to Hetzner. Should I just move to Hetzner now? Because my guess is that for me to be able to do this, I need to be able to set up some pretty kernel level stuff. So I assume that's not going to be allowed on Fly.io. And then for me to be able to take over, and it'd be fun to be able to be like, hey, the rate in which you're sending packets is not allowed. Like, be able to ban people at super ridiculous levels would be so fun. So that could be, there you go. So people always say this kind of stuff like, oh, how do I learn? This is literally how you learn. What I'm doing right now. You literally just come up with an idea and then try to do it. Like, that's it. It's just tinkering, right? How do I learn? What I'm going to do is I'm going to go here. I am going to read these things, right? We're just gonna read all of these, and then we're gonna crack open eBPF, even though I've never used it, nor do I have any idea how it works. We're just gonna try it, right? That's how you do it. Why do you use mocks instead of test containers? I don't really understand what you're actually asking here. Those are vastly two different concepts, and it's impossible to understand that. Hey, the name is I'm definitely not sponsored by Nike, though. Think about it, Nike. Let's think about this, Nike. If you wanted to sponsor a tech streamer, hear me out on this one. Dude, we can just say, just do it. After everything, you know what I'm talking about? You see where this is going? Please. And look, Flip, dude, he needs it. He's been eating beans and rice being my editor for months. Do you realize how much crap he has to listen to? Dude, send me some stuff. Sponsor me. It will go viral because you're sponsoring a tech streamer to say just do it for doing projects. So not only that, you're also encouraging people to build and become better educated. I'm just saying, lots of wins here. Lots of wins. Lots of W's, and I'd also love $10,000 a month. Like, that sounds great. Okay, it's just, dude, $120,000 between friends, that's nothing. Okay? You sneeze and you accidentally spend $120,000. It's like not even a big deal, right? Not even a big deal, Nike. And I'm going to get a mullet, which even is probably better on brand. Straight up, yeah, straight up. Think about it. Again,